Okay, today we are going to be solving quadratic equations with three different methods. It's nothing new, nothing we haven't learned already. It's just taking some skills we already know how to do and using them all, practicing them all, and seeing how they relate to each other. So the past couple days, we've really been working on completing the square. You took notes over that yesterday, and we did some examples in class, and the quadratic formula. That's where we need to plug in A, B, and C. Also, earlier in this year, we learned how to factor. Remember, that's where we use the x here, and we put a number up top, say something like, I don't know, 4, and we put a number down bottom, like 5, and we got to figure out what multiplies to the number up top and adds to the number below. So here it'd be 4 and 1. We're going to use factoring as well as completing the square and quadratic formula in order to solve these quadratic equations. So as I pointed out in class, I think it was yesterday, or at least the last couple days, when you solve a quadratic equation with completing the square, or with the quadratic formula, or even with factoring, we should get the same answer each time. So what we're going to do today is take a single quadratic equation, solve it all three different ways, and see if we get the same answer. Now, one thing to note, factoring is not always possible. We will run into some cases where we have something like this. Let's say multiplies to 5, but adds to 2. If you take some time to think, what could multiply to 5? Well, it's 1 and 5. Does that work here? 1 and 5? Nope, those don't add to 2. Or it's -1 and -5, I guess, multiply to 5. Do those add to 2? Nope, that doesn't work either. And there's no other integers, whole numbers, that multiply to 5. So we'd kind of be stuck with factoring at this point. So you will run into cases where it is not possible to factor. That's why I have up here using factoring if possible. Always got to check to see if we can do it. Okay, so let's take this equation, 4x squared minus 10 equals 3x, and solve it in these three different ways. So first of all, we're going to go with factoring. So in order to factor, we need to set up our equation similar to what we do with the quadratic formula. We need to get everything onto one side and 0 on the opposite side. So when I subtract the 3x over, I get 4x squared minus 3x minus 10 equals 0. Okay, now this is one of those tricky problems to factor. So I'm going to make my x right here. And what I need to remember for factoring is I have to multiply these two numbers together. So 4 times -10 to get what goes up top. So that's -40. So I have -40 up top, and I put the -3 down bottom. Okay, so we need some numbers that multiply to -40, but add to -3. Well, let's just think of some things that multiply to 40. See if they're maybe just off from each other by 3. So we've got 20 and 2. No, those are too far apart. 10 and 4, they're apart by 7. 8 and 5, those are just off by 3. So if I pick the correct signs, 8 and 5 should work. So how about -8 and +5? Multiplies to 40, or to -40, and adds to -3. Okay, so this is one of those factoring problems where we have to split the middle term. So we get 4x squared minus 8x plus 5x minus 10 equals 0. Okay, so I use my two numbers from my factoring to split the middle term. The next step is to group the first two terms and group the next two terms and factor out a greatest common factor from each pair. So in the first pair here with 4x squared minus 8x, I see that both are divisible by 4 and both have an x in them. So I'm going to pull out a 4x. Okay, so if I divide out a 4x here, this first term, I'm left simply with an x. And in this last term, I'm left with minus 2. Now, quick reminder, when we factor out from both of these parentheses, we're hoping that we're going to end up with the same thing in our two remaining parentheses, an x minus 2 here, and when we factor out over here, an x minus 2 as well. So let's keep that in mind as we go forward. So here with 5x and negative 10, I can divide a 5 out of both of them. So I'm going to put plus 5 because it's a positive 5. And then in my parentheses, when I take the 5 out of 5x, I'm left with x. When I take it out of negative 10, divide it out, I'm left with minus 2. Okay, so I've got this. It's still equal to 0. And now I've got x minus 2 in both my parentheses. That's perfect. I take the 4x and the plus 5, and those are going to form one set of parentheses. So I've got 4x plus 5. And I take the x minus 2, and that forms my second set of parentheses, times x minus 2. And continue to have that equal 0. Okay, so I've got one set of parentheses here, 4x plus 5, multiplied by another set, x minus 2 equals 0. This is the zero factor property. When you have two things multiplied together, or three things, or 10 things multiplied together to equal 0, you know that one of those things that is multiplied has to be 0. So I can take each one and figure out, well, how could 4x plus 5 equal 0? What would x have to be? Or how could x minus 2 equal 0? What would x have to be? So if I solve here, I've got 4x equals negative 5, and finally x equals negative 5 over 4. And then in the other case, I add over the 2, so I get x equals 2. So I got x equals negative 5/4, or x equals 2. And I'm going to put a box around these. This is our final answer for factoring. Okay, we could take those answers and plug them back into our original equation up here if we wanted to check. And when we plug them back in, hopefully we'll find that we do get both sides being equal. However, we can check by solving the same problem in a different way. Let's do completing the square. So 4x squared minus 10 equals 3x. So I'm going to draw a line here just to show that I'm going to a different method. Squiggly line, and let's do a different color for this one. Let's do this one in green. Completing the square. Okay, for completing the square, I'm going to go ahead and get my x squared term and my x term on one side, and then my constant term on the other side. So I'm going to look back up at my equation real quick. So from here, I want the 4x squared and the minus 3x on one side, and I'm going to move the 10 over to the other side. So I got 4x squared minus 3x equals 10. Okay, now whenever I complete the square, the first step, hopefully you've got your steps out and you're following along, and maybe you even are a step ahead of me because you know what to do, is to get rid of any coefficient in front of the x squared. So I have to divide everything by 4. So 4x squared divided by 4 just gives me x squared. When I've got negative 3x and I divide it by 4, I get minus 3/4 x, and then equals 10 over 4. Now, you are more than welcome to go ahead and simplify that 10 over 4 if you'd like. When I'm completing the square, I like to save my simplifying for later on in the problem, but there is nothing wrong with doing it right now. Okay, so, and another point. Instead of writing this as 3x over 4, since we really want the coefficient with the x, I think it is more helpful to write it as 3/4 in front times x. Those mean the same thing. The way it's written over here, the 3/4 in front of the x is just going to make the next step easier for us. Okay, now is where we do the actual completing the square. We have to decide what we're going to add to both sides. So what I do is I take the coefficient in front of the x, that's negative 3/4, and I multiply it by a half. So negative 3/4 times a half gives me negative 3/8. Effectively, all you're doing is multiplying the denominator by 2. So that's half of that. And then I take what I have there and I square it. So that's really just squaring the top and the bottom. So I square the top, I get 9. And I square the bottom and I get 64. And it was negative before, and I squared it, so a negative times a negative gives me a positive. So it's just 9/64. This number is what we need to add to both sides in order to complete the square. So I'm going to rewrite all that I've got. So x squared minus 3/4 x. And then this is the constant term I need to add in. So plus 9/64. And if I want to add that to one side, and I want to keep this equation the same, I don't want to change it, I want to add it to the other side as well. So I have 10/4 plus 9/64. Okay, in our next step, we're going to factor the left-hand side. The left-hand side is always going to factor perfectly. You don't need to do any work. You don't need to draw an x to figure out how these three terms, this x squared minus 3/4 x plus 9/64, factors, you don't need to do anything. It's always going to be right here. This thing right here is going to tell us how to factor. So we get x, and it's negative 3/8, so minus 3/8 squared equals, and then on the right-hand side, I'm going to need to get a common denominator in order to combine those two fractions. So I've got 9/64 and 10/4. I'm pretty sure that 4 goes into 64, so I would check maybe on my calculator to figure out what's 64 divided by 4, so I can figure out how to get a common denominator. So I've got 10/4 plus 9/64, and what I need to do with this first one is multiply it by 16/16. So if I multiply the top by 16 and the bottom by 16, I'm going to get this one as having a denominator of 64. Okay, so that's going to be, I'll rewrite my left-hand side, x minus 3/8 quantity squared equals, this is 160/64 plus 9/64. And I combine these and I get 169/64. Okay, so let me actually just rewrite this equation here without this middle step so that we can see clearly what we want to do next. X minus 3/8 quantity squared equals 169/64. We're trying to solve for x here. We're trying to get the x by itself, and it's stuck here inside this parentheses, stuck here inside the stuff that's being squared. So what we need to do is go ahead and square root both sides. So on the left-hand side, I just get x minus 3/8 because the square root and the squared undo each other. And on the right-hand side, I get square root of 169 over square root of 64. Okay, because when I take the square root of a fraction, I can split that up and do the square root of the numerator and the square root of the denominator. Now, hopefully you're seeing some simplifying that we can do on this right-hand side. So I've still got x minus 3/8 over here, not doing anything with that yet. And on the right-hand side, oh, I forgot something. Hopefully you've yelled out in class already, hey, Mr. Crouch, you forgot your plus and minus. Good, I hope you all yelled it out right there. So I need my plus or minus here when I square root both sides. So I'm always going to just leave the plus or minus with the top thing when I split my square root. That's going to make things simpler for me. So let's simplify now. Square root of 64 is 8. Great, 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 because now we have a denominator of 8 over here and a denominator of 8 over here. And square root of 169 is 13. So plus or minus 13. Okay, let's keep going. So I've got x minus 3/8 equals plus or minus 13 over 8. Trying to get the x by itself, so let's go ahead and move the 3/8 to the other side, add it over. So I've got 3 over 8. I'm always going to put this term out front and leave my plus or minus thing later on. Plus positive or negative 13 over 8. This is just going to make things simpler sometimes when there's square roots. I know it may look a little weird instead of having the 3/8, see if I can drag it, added on at the end, which is what you would probably normally do, what your first instinct might be. It's a lot easier sometimes if we just put it out front. Now these have a common denominator, so I've got x equals 3 plus or minus 13 over 8. Now this is simple. There's no square roots in here, so let's actually evaluate what we get with the plus and the minus. So x equals 3 plus 13 over 8, or x equals 3 minus 13 over 8. So 3 plus 13, well, that's 16 over 8, which simplifies down to 2. So x equals 2 in that case. Or 3 minus 13, that's x equals negative 10 over 8, which both of those numbers are divisible by 2, so x equals negative 5 over 4. So x equals 2 or x equals negative 5 over 4 from completing the square. Let's look at what we got when we were factoring. It's a lot to scroll through. Negative 5 over 4 or 2. So we got the same answer here, solving the problem two different ways. I'll put a box around this answer just like I did up there. X equals 2 or x equals negative 5/4. Awesome. Same answer, two different ways to solve it. Which one was easier there? Probably factoring, but might not always be the case. We got one more method to do. Draw another line. Our final method is, let's use a new color, haven't used blue yet, quadratic formula. Quadratic formula. Okay, I'm going to get my equation back from the top. So we got 4x squared minus 3x minus 10 equals 0. All right, let's write that down here. So I've got it. 4x squared minus 3. Now I'm already forgetting it. Is it minus 3x? Yep, minus 3x minus 10 equals 0. Okay, the quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all divided by 2a. So I'm going to use my equation over here to figure out what a, b, and c are going to be. A is always the coefficient of x squared, so we got 4. B is always the coefficient of x, so we have negative 3. C is always the coefficient of the constant term, or the constant term by itself, negative 10. Now I'm going to plug everything into the quadratic formula, being careful to use parentheses for anything I plug in. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, I put parentheses around every single value that I plug in. This helps me to not make any careless mistakes when I'm simplifying here. So now I have x equals, I have -3 here. So that is 3 plus or minus. There's my square root. And I have -3. Thank goodness I remembered those parentheses. -3, the whole thing squared, gives me 9. And then remember, at least in my method, I'm leaving this minus sign here, the one that my mouse is over right now, leaving this minus sign here and doing the multiplication that comes after. 4 times 4 is 16, times -10 is -160, and then all divided by 2 times 4 is 8. Okay, now I will simplify in the square root. So x equals 3 plus or minus square root. 9 minus -160 becomes 169 over 8. And 169, we just did completing the square, and this popped up for us. So we know that the square root of 169 is 13 over 8. And now all I have to do is split this into 2 problems and evaluate both of them. So I've got x equals 3 plus 13 over 8, or x equals 3 minus 13 over 8. And these are the exact same problems we had when we were completing the square. So 3 plus 13 becomes 16 over 8, which equals 2. And 3 minus 13 becomes -10 over 8, which simplifies to -5 over 4. So we have x equals 2, or x equals -5 over 4. Which, thankfully, since we've done this 3 times, I remember that those are the same answers I got with factoring and with completing the square. Okay, so as you're working on these problems on your own, make sure you have out your notes that has the quadratic formula on it if you don't have that memorized yet. Make sure you have out your notes that you took yesterday that show you how to complete the square. And make sure you can get out your notes that has the steps for factoring on it if you need a refresher in that. All right, thanks, and you'll do great.